Welcome to the video lecture Digital Principles and System Design Unit 5 Memory and Programmable Logic Devices. In this video lecture we are going to see memory, its types, and we are going to focus on random access memory and its types. So these are the fifth unit contents: basic memory structure, read-only memory, random access memory, and programmable logic devices, PLS, PALs. So unit 5 we can split into two halves. First half consisting of memory elements, and then second half consisting of programmable logic devices, PLDs. So in the first half we are going to see in this video we are going to see the first half of the fifth unit, that is random access memory and its types. First we will see what is memory and how it is classified, and then random access memory and its types. Before going to see what is memory, have a look into this slide, this picture consisting of all digital systems. So every digital system, to process the data, to store the data, previous data, it needs a memory. So memory is a part of every digital system nowadays. It maybe needs a small amount of data, it maybe needs a huge amount of memory. So every digital system, the memory must be compulsory. So memory, what for memory? It is used to store the computer data, to run the programs. It may be instructions, it may be whatever may be the data, it may be program or input data. So to store those data, it needs memory. So memory is broadly classified into primary memory and secondary memory. So this is the broad classification of memory. Under primary memory we have a random access memory and read-only memory. Coming to secondary memory, it is external component of the computer, that is DVDs, CD-ROMs, hard disk, floppy disk, all comes under secondary storage devices. So under primary storage devices, under primary memory, RAM and read-only memory, ROM, will come. Now let us see the basic memory structure, how it looks like. So memory unit chip, it consists of a collection of storage cell. So each and every storage cell will be used to store the bits, either zeros or ones, and these stores information in terms of groups of bits called as words. So 8 bits, group of 8 bits called as a byte. So this word may represent a number, an instruction, or one or more alphanumeric characters, or any binary information. An image can be converted into digital ones and zeros. So image can be stored as ones and zeros. Video can be converted into ones and zeros. So any information is converted into digital ones and zeros, bits, and group of bits will be stored in the memory. So each word stored in memory have a location. That location is specified by an address. And communication between memory and its environment is achieved through the data input-output lines, address selection lines, and control lines, which specify the direction of the transfer. Let us see the basic memory structure. So this is the basic memory structure. It consists of k address lines. Here k representing 2 power k representing number of address lines. Here for example k equal to 4, then 2 power 4 is 16. This memory will consisting of 16 rows, and here n data lines. If n equal to 8, that means 8 data lines will be there. That is columns for this memory is 8 columns. So memory is organized as rows and columns. Rows will be given by 2 power k, that is address lines, number of address lines, 2 power k, and n data lines representing columns. For example, it is 8, means 8 columns will be there. Now read write control signals. If read is active, that means we are going to take the data from the memory. Write operation means we are going to enter the data into the memory. So those way of, that is transfer of data within the to the memory or from the memory, will be controlled by these control signals. So it has k address lines to address or access the 2 power k in the memory, 2 power k rows. It has n data input output lines through which the data is transferred in and out of the memory, and it has 2 control inputs, read and write. Now the write input causes binary data on the input output line to be transferred into the memory. Write operation means we will transfer the data into the memory. Read operation means we will read the data from the memory. So data is transferred out of the memory. So selection of specific word inside the memory unit is done by applying the k bit binary access to the address lines. So the location will be given by address lines. Now the types of memory. Memory is classified into, that is the primary memory is classified into 2 types again, RAM and read only memory. RAM again classified into static RAM, dynamic RAM, and ROM is classified into programmable read-only memory, erasable programmable read-only memory, electrically erasable programmable read-only memory. So these are the differences between RAM and ROM. Random access memory, it is used for temporary storage. Read-only memory is used for permanent storage purpose, and RAM is volatile, that is if power to the chip is off, then it will lose the data. Non-volatile means even though power is not present or not given, then also it can able to hold the data, that is ROM is non-volatile. Writing data is faster. Here entering the data into the chip is faster in RAM, writing data is slower in ROM, and it is used in normal ALU operations by the CPU. ROM, coming to ROM, it is used for startup process like bootstrap programming, basic input output program, BIOS programming. For that operating system, so memory is stored in read only memory. The permanent programs will be stored in read only memory. Next, random access memory. So it is present on the motherboard, and computer's data temporarily stored in RAM. So it is volatile. Volatile means the memory will be lost the data if power is gone. As long as power is supplied, it will hold the data. So here it is also called as read-write memory, since the CPU can able to read the data from the memory and it can able to write the data into the memory. So it is also called as read-write memory. So this is the black diagram of read-write memory. Here it is consisting of n address input lines to access 2 power n memory locations, and m data lines to read and write data from to memory. So n bit address lines is placed in the memory address register to select one of the 2 power n memory locations. So read and write are control signals. So here we are having a read write control signals, and the figure it is showing read write control signals. So if read is active, then read operation will be performed. Write is active, then write operation will be performed, and the location is given by these n bits address lines, and the data will be taken out from the here m data lines will provide. Read operation means the direction will be like this, and write operation means into the memory. So this is the black diagram of read write or random access memory. Now the types of random access memory. Semiconductor random access memory is classified into 2 types, static and dynamic. The static RAM employs BJTs or MOS flip-flops. Dynamic RAM uses MOSFETs, metal oxide semiconductor field effect transistors or capacitors to store the data. To store bits ones and zeros, static RAM uses BJTs or MOS flip-flops. Coming to dynamic RAM, to store ones and zeros, it will use metal oxide semiconductor field effect transistor or capacitors. And then either case both are volatile, that is as long as the power is given, it can able to hold ones and zeros. If power is gone, it will also lost, data will be removed. So this is showing types of random access memory. So two types of manufacturing process: bipolar metal oxide semiconductor. If it is bipolar, static RAM only available case; metal oxide semiconductor, both the cases are available. So in static RAM, since it is storing data using transistors, it can able to hold the data as long as power is supplied. As long as power is there, it won't lose the data. And memory capacity, it is available 64 bits to 1 megabyte, 1 MB memory is available, the chip capacity. Coming to dynamic RAM, it is storing memory on capacitor. It needs periodic refreshment. If there is no periodic refreshment, even though power is supplied, the capacitor will lose the data. So if there is no periodic refreshment, dynamic RAM will lose the data. And the memory size is ranging from 16 to 256 megabytes MB. So large highest density is available in dynamic RAM compared to static RAM, bulk size memory. So now let us see the differences between static RAM and dynamic RAM. So SRAM uses transistor to store a single bit of data, either 1 or 0. One transistor is required. Dynamic RAM uses a separate capacitor to store each bit of data. So here transistor will be used, here capacitor will be used. SRAM does not need periodic refreshment since it is storing data using transistor. DRAM needs a periodic refreshment since it is storing data in the capacitor. SRAM structure is complex compared to DRAM since it is using capacitor to store each bit. It is using a capacitor, so DRAM is simple compared to SRAM. SRAM are more expensive, DRAM are less expensive. SRAM are faster than DRAM, DRAMs are slower than SRAM. And SRAM are used in cache memory. So computer, cache memory is used to store the data which needs to access fast, quick. For quick accessing, we will use this cache memory. So SRAM cells are used in cache memory, and DRAM is used in computer main memory. So these are the advantages of RAM. It is non-destructive readout. So how many times we can able to read or write, we won't destruct the chip. Fast operating speed and low power dissipation. There is no power dissipation, only milliwatt power will be dissipated. And compatibility, it is compatible with all the devices, and economically it is feasible. So I hope you understood what is memory and classification of memory, that is read only memory, random access memory, and then about random access memory where we will use. So for internal calculation purposes, temporary storage of data, we will use RAM, and then types of RAM: static RAM, dynamic RAM. And RAM is volatile. Volatile means if power is off, then it will lose the data. So in SRAM it will used in cache memory, and for main memory we will use DRAM. Thank you.